Okay, looks like yeah. Yeah. Hello. Hello, everybody. Yeah, looks like we are live. Okay. So hello, everybody. This is Daniel Suguwa. Yeah. Apologies for quite a delay. I should have already live around 10:40 a.m. or around 17 minutes ago, but due to some unforeseen circumstances, unfortunately, uh, I cannot go in live on time. But however, we are still going to cover maybe a little bit more thing, and yeah, looks like I need to find here. Uh, just a little bit moment. So yeah, you cannot see it there, right? I'll show. Okay, so this is a little bit of informational. I'll stop here.
We see every part of this orbit.
Yes.
Why is that
So,
important for the SPHEREx
how does it sound?
mission?
Is it okay?
For SPHEREx, you can't look at the spacecraft without seeing this large cone on top, and that's because this is
Yeah.
a photon shield designed to protect the sensitive instrumentation
Oh, okay.
inside.
Looks like
And
it's
what
okay.
sensitive to
It's
is
okay
to
on
the
my
sun.
feet.
So with the sun always in this direction, that means we
Yeah.
know the sun's
So-
over on this side. So that's the
So that's
safe
it, guys.
side. So that's
Because
where the SPHEREx can go ahead
because
and
of that
operate
slight
in the
delay,
orbit
I
in this
will try
direction, do
to
the
cover as much as
celestial
possible
sky
about the current
observations,
mission,
always working on this
which
backside
right now
of
we are
the
going
safe
to
side.
witness
Punch, on the
the
other hand, is
SPHEREx
exact
and also
opposite. It wants
Punch
to study the sun.
satellite
It
that
wants to
will
see the
launch
solar wind, the solar weather emanating from the sun
the
toward
altitude
Earth. So this is a perfect orbit
around
for them. It's to
around the
follow around
sun-synchronous
because they'll
orbit,
go ahead
or
and get
basically
maximum viewing time with the
just another
sun.
fancy way to say is that it will always get those
Made up of 4 satellites.
daylight,
SPHEREx is one. So
aka
basically, you have 5
sunlight,
spacecraft
basically a
that are
daily
relatively,
sunlight
near each
for
other
it
as it's
to
going around the Earth. How do you make sure that
orbit
they don't interfere
around
with one another?
the
Right,
Earth.
sure. We
That's
do a couple
one thing
things
for
because
sure.
you're right. That is
So
very important. First
yeah,
thing is SPHERex is going to go ahead and separate. We're gonna
I'll
get
give
the
you a
sun,
little bit of
obviously, so we're gonna
overview
separate
here
this
because
direction.
we are
After
not
SPHERex separates,
having
the Falcon's
enough
going to do a
time,
small attitude lowering maneuver
how
with their attitude
how
control
we are
thrusters,
going to do.
just to lower by
So
a couple kilometers. So they're not exactly the same orbit. And then the Punch
okay,
spacecraft we're going to separate
I
in
think
different directions.
what should
So
I
the
do
first
is
two Punch spacecraft we're going to separate equal
I'll
and
just go
opposite
here.
along the velocity vector. The other two canted off that vector. So
Okay, let's open the music. We ignore that first because not too important. Okay, I'll just open here. Yeah. so so in theory you should be able to see what's happening, right? It's here. Okay, looks like it. Okay, go. Ooh, ooh, very good. Very laggy on my side. Okay, but anyways, I'll try to cover. What's happening is that we are going to witness the SPHEREx launch, which actually SPHEREx stands for Spectro-Photometer for the history of the universe, Epoch of Reionization, and Ice Explorer or SPHEREx. That's for sure, and it's going to operate around 27 months or around, or if we have already minus everything there, including commissioning 1 month and also decommissioning 1 month, it will operate around 25 months or around 1 year and a month. So it will okay, and so for yeah, and looks like it for this SPHEREx, it will specifically try to go with polar orbit at around day and night terminator line, or maybe just another way to say it's SSO, sun-synchronous orbit. That's one thing for sure. And also, let's go a little bit with the overall dimension here. It says here it's around 8.5 feet or 2.6 meters tall and 10.5 feet or 3.2 meters wide and deep. It says here, and has solar panel around 8.75 feet by 3.4 feet, or for us metric enjoyers, we will use 2.67 meters by 1.02 meters, which should be able to produce around 750 watt of power. So the total weight or mass here, I think, include fully loaded, it will be around 1,107 pounds, or around 502 kilograms for us here. And maybe you might be asking, what's going to be use case for this SPHEREx? Yeah, that's we are going to cover later. Not going to be that long. So this is how it looks like. There is instrumentation inside here, and it's covered by 3 layers of spherical protection. So it will protect against incoming boatload amount of photons. Whatever elements that will how do I say, that will interrupt the viewing session, especially. So by having this protection around, at least we are able to study about our universe in wide variety, for sure. And remember, this is a wide survey telescope, not that specialty mission focused telescope. So please remember, that's one thing for sure. And it does have around effective diameter of 7.9 inches or 20 centimeters for us here, and it says it has an 11 degree by 3.5 degree field of view. So it will try to take about 600 exposures of sky each day, and so we'll try to survey all the entire sky about once every 6 months. So it should be able to complete all 4 of it in its all sky maps in its, it says here, around 27 months of primary missions here. So, and also it's going to break around 102 wavelengths of near infrared light, mostly to study about the composition of the universe. So what is going to, okay, didn't you? Okay, so yeah, for here it's going for 650 kilometers, or around 404 miles for you guys anywhere else not using metric. Okay, and it just say here, so it's going to sun-synchronous, so it will be, orientation would be related to sun, that would be remain consistent throughout it. So yeah, because it's very important, you want to light up the satellite, right? But at the same time, you want to be protected against all of that heat, especially the photon and whatnot that will overwhelm the CMOS. Not CMOS, maybe not necessarily. It could be like the camera sensor system here. So it's protected by here, and it should be cooled down up until, if I remember, around minus 180 plus, 200 plus, minus 200 plus degrees Celsius, around the chill point of liquid hydrogen. You know, it's pretty cold, or maybe around nitrogen, helium, I guess. And to show you a little bit what's going to be the science goals and objective for SPHEREx, it will not only will try create 3D maps of the universe, but it will be used to study the inflation, which is, it says here, the rapid expansion of the universe by a trillion fold in less than a second of the Big Bang. That's one thing for sure, and we'll try to collect all of that light that may be hidden or missed by a lot of telescope out there. And also we'll try to search the Milky Way galaxy for hidden reservoirs of water, carbon dioxide, and other essential ingredients for life. Maybe, for example, acid amino and what's on, and it will try to measure their abundance and availability for newly forming planets. That's one thing for sure. And how it will try to capture it? It will using the technical spectroscopy, similar to the how do we use the prisms, right, to break the sunlight into the rainbow, so we can study the composition. For example, I can show you here. Let's say this is one of the example, okay, from the James Webb Space Telescope. You see, you can study how and what's on. Okay, and this is how it looks like. How they are going to study using this spectroscopy. Okay, and yeah, you can see this is how they will how they are going to study all of it. Pretty similar, right? So okay, looks like pretty good. And I'm going to cover for punch, which punch actually stands for Polarimeter to unify the corona and heliosphere. This one will be used to study the sun. Yeah, essentially heliophysics out there. So if you guys actually study about the suns too, congratulations, this mission is also for you. And for the astronomer, SPHEREx, this one also is for you. So a win-win for both situations. Okay, so I'm not going to show too much, but for the wide field view, the WFI, it's going to, if I remember WFI, the wide field instrumentation, it only have around, yeah, it has 3 pairs of it. Okay, they will study in wide view for the sun. Okay, and it should have around 90-degree wide field view for of the sun. Okay, and on top of that, there is also going to be a near field instrumentation, which only consists of one satellite there, one out of 4 pair of satellites that they will be used to study very, very specific of the sun. Okay, it's going to study very specific of the sun. Maybe let's say, for example, maybe they want to see what happens in on the interaction in action, right? So that's how it's going to use. Okay, and this is the mission, how it looks like. And the spacecraft dimensions is around, it has 440 pounds or around 64 kilograms, which should be totally amounted to 256 kilograms or around let me calculate, 560 pounds for each for every total of these small satellites here, and would be around 1 by 2 by 3 feet or 0.5 by 0.7 by 1 meter in size, around the briefcase size. Okay, and also this is also will be targeting to SSO, sun-synchronous orbit, or another way to say is heliosynchronous orbit. So it's pretty useful, right? And this is how it looks like. This is the WFI. There's 3 of it, a little bit different, and also the narrow field imager. Sorry, all of it were actually called WFI, wide field imager, and this one narrow field imager. This one is the coronagraph. They will block out the bright sun to better see the details of the sun's outer atmosphere, while the WFI would be the heliospheric imager. It says that it can provide views from 18 to 180 solar radii, or around 45 degrees away from the sun in the sky. And it will try to use the artificial horizon and deep baffles to view the sun, the very faint, 30 seconds outer portion of the solar corona and the solar wind itself. So not going to have much time, so let's go back to live. Let's go. I will try. Okay, 10 seconds. Okay, to my 8, 9, 7, 6, 5, 4, 3, 2, 1. Ignition of the Merlin 1D engine. All 9 engines already up, and lift off from the launch pad, and it's already cleared the tower. And now on the way to the yeah, and when it says space weather forecasting, it's mostly directed to the sun. Yeah, because you need to remember that all of that sun, especially the how do we say it, when the solar flares, very extremely strong solar flare heading to our it's going to be very, very catastrophic. Unfortunately, as far as I know, recently we are still surviving, so pretty good.
Slightly in order to prepare
Okay,
nominal.
okay,
in order to
motor
prepare
is nominal.
passing through max Q, and that is
Okay,
maximum aerodynamic
around the
pressure.
speed is
That's below the structural load that the
1050
vehicle will
kilometers
see
per,
during
per
descent,
hour.
slowing the vehicle down.
Okay, it should have already been supersonic right
Slowing
now,
the vehicle down will reduce some of the
and it should be
loads
max
that it
Q.
experiences
Okay,
through
as you can see,
max
this
Q.
is the
That's coming up here in a few
how do I
seconds.
say the okay right now
Right on
already
time.
reached max
And now we
Q,
have a few
pretty
events
much
that
on
are coming
time.
up in quick succession, so we want to lay them out for you really quick.
Okay,
It's
so
gonna
max
start
Q
at
would be
main
the
engine
maximum
cutoff. It's
dynamic
MECO,
pressure that would
and that's when
fully
SpaceX shuts
exerted
down
on
all
the
of its
launch
9
vehicle
engines on its first
stuff,
stage,
and
we are
if
getting
it
a
fails
great
around that,
view
yeah,
down
you
the
can
pipe right
you
there.
can expect it's
Shortly
going
after
to
that, stage 1
no
and
longer
2
proceed, maybe
separate
even
from each
explode.
other,
But in
and
this case,
seconds later,
it
the first
really
stage
passes
will
max
flick
Q, and
back towards Earth, while the second
unfortunately
stage
looks
will
looking
continue
very good
on,
so far, and
igniting its
looks like we
F9
have
engine.
already
Now that call out is
going more
second
than Mach
engine
2 right
start
now.
1 or SE1, and
Altitude
this
is
burn will last about
31
6 minutes.
kilometers.
After that, the boost back
Speed
burn on
is
the first stage to
or
put it back on
velocity is around
trajectory towards
3,600
landing
kilometers
zone 4,
per hour.
which again is back here at
And once again,
Vandenberg,
we can see
just about 1,500 feet from
maybe
where
we've
Falcon
already
launched from in the first place.
almost reaching
Wow,
Mach
look at that shot.
4.
All Merlin
Okay,
engines firing right there, and we have such
okay,
a
it should be
great
around
live
Mach
shot
4
of it.
right now. Okay, and we are going to ready to see the interstage separation between stage 1 and also the stage 2. Okay, upper stage is already chilled by then, and now we have already shut down of the all 9 Merlin 1D engine, and let's go with the Merlin 1D vacuum engines. Okay, it's already separated, and ignition of the second stage. Okay, looks there. That's beautiful, beautiful plume there. Looks like we've already confirmed. Also uh, from this. Oh, you can see there. It looks a little bit like a jellyfish there. Beautiful shot of the launch vehicle. Okay, and looks like the first stage booster already heading in, heading with back toward the. If I remember, it's not going to be launch pad. Should be around the drone ship. Okay, this is the fairing view and should be fairing short separation. Okay, fairing fairing jettison, and here we go. Here what we can see at the top of it is the SPHEREx telescope satellite there. You can see, looking pretty good. Okay, the first stage is still making its return back to home. Okay.
Stage 1 boost back shutdown.
Okay, stage 1 boost back shutdown, it says. Yeah, as you can see, it's pretty interesting. That's one thing for sure.
The first of 3 burns that it needs to make its way
Okay,
back down to Earth.
hopefully you guys
This
can
is the
still see.
third flight for today's first stage, which previously supported 2 other launches, NROL
Okay,
186 in
so I
November of
can give you
2024
some
and
little bit
Transport
brief
12
vision
just
what
in January of this year.
how it's going
And
to look like
you may
here.
have noticed some soot on the vehicle prior
Okay,
to launch
so this
during
is
the
how
entry
it will
burn, which is
separate
coming up here
separate
in a
for the
couple
punch
minutes.
satellites
The
there.
Falcon 9 is decelerating by
And
reigniting 3
for
of the 9 Merlin
uh,
1D
the
engines.
timeline, as
Now,
we
this
can see,
causes the
it's
vehicle to
already
fly
been used
through Merlin's
in
exhaust
Suck
gases,
Station
or
for
the
the mission.
plume, which deposits a layer
Let
of
me
soot on the
see
vehicle's
here.
surface, and that soot comes from the carbon-based fuel that Falcon 9 uses with
Okay,
each flight. The
let me
soot builds up
see.
just a little bit
Should
more on the
be
outside of the vehicle,
fun.
giving Falcon 9 its distinctive reused look. We're just
Never
so
mind.
lucky to have these great views. Again, we have a split screen here. On the left side
Yeah,
is
never mind.
the first stage, and you see those
Just
green
enjoy the
fins. They're
view for
guiding
now.
that first
I'm
stage back to
going
a
to search.
trajectory here at Vandenberg Space Force Base. And then on the the right-hand side on your screen, you have the second
Yeah,
stage, and you see that MVAC engine is still burning there.
looking at that, pretty good.
LSP just works really closely with SpaceX to be able to fly reused rockets for NASA missions.
Yeah, Megan,
So for the
at
key
OSP, we
mission,
look at all the requirements for all the missions that we have. And
I
as I
can
said earlier,
I
we
can show you
selected
now.
SpaceX for the SPHEREx and Punch mission. And looking at all those
Okay.
requirements, we ensure that even previously flown
Okay,
launch
for the
vehicles
key
will
events,
meet
we've
those
already
requirements,
reached the
providing NASA
MECO
with a dependable
second
and
stage engine
cost-effective
start
ride
number
to
1.
space for this,
Already
first Voyager
fairing
mission.
jettison,
Yeah, If you're just joining us,
And
hello,
we
we're
are
in your
waiting
bottom
for
corner
the
right there.
Pico
I'm
one.
NASA's Megan Cruz, and with
Okay,
me is Mick
so
Wolfman with NASA, and
let's
also
watch for
Jesse
that.
Anderson, a senior production manager
Okay,
at SpaceX. Now, Mick is
so
with
let's watch
NASA's
for
Launch
that.
Services
We are going
program,
to
which
see.
is managing today's launch. So he's going to have a lot of interesting things to say to us to walk us through what we're seeing
Yeah,
today. And of
one thing
course, we
for
have
sure.
Jesse from SpaceX. Really great ride so
Okay,
far,
so
and
the
we're so lucky to
mission
have you guys.
is around
And you know,
almost
LSP
T
chose
plus
SpaceX to
6
deliver
minutes,
SPHERex and
looking
Punch
pretty
to what's
good.
called a
And
sun-synchronous
looking
orbit,
at the mission profile
650
too,
kilometers above
I
the
should be
Earth.
able to
And SPHERex
complete
is
my
going to help
obligation
answer
before,
some of the
uh,
biggest astrophysical questions out
how do I
there.
say
You know, like
before,
how do
before I
galaxies
have to
form
head
and
for the
evolve?
class. So
How
that's
water
one
and
thing
other
for sure.
key ingredients for life came to
So
be.
looking
And then
pretty
Punch
good
is made
there.
up of 4
It's
satellites
pretty
that will study
expanded
the
there
sun
on the
and
vacuum
see
side.
how it
You can see
creates
why.
space
Because
water that can significantly
you
impact
need
us
to
on Earth.
remember
I mean,
that
Mick, we're talking about like
this is no longer at the
we're talking
atmosphere
about
very
issues with GPS or
pressure
satellites,
anymore.
things
So
like that.
there's
Yeah,
no
it's
longer
maybe.
going to
Entry
be
burn
that kind
startup.
of okay.
And there we
Looks
heard
like we
the
have
call for the first stage entry burn
entry
startup.
burn startup
Looking for
for the
entry
first stage.
down here
Should be
in just a
around
few seconds and getting ready for landing
few
burn
seconds or maybe
in
around
just
30
about a
seconds if I
minute.
remember correctly. So let's see.
Stage
Okay.
1 entry burn shut down.
Okay, stage
There
1
we
entry
have
burn
Jesse confirmed
shutdown.
stage
Okay,
shutdown
looks
for
pretty
landing
good.
burn.
And
Back
not
over to
going
your
to be that
side,
long. It's
Mike.
going to be
The
good.
science of the
Oh,
mission. I
pretty
know Farah
beautiful.
is sitting there looking
There is a
perhaps
view of the
liftoff tonight.
of the
But you
Earth.
know, the most
Uh,
important thing about these two
maybe
missions is
returning back
exactly what
to
you were talking
the
about.
Tron
Once we
ship
get them
or
deployed, the science that they will
almost near to
have
the launch
to be
site.
able to
Let's see
help
what
us
happened
here
by
on Earth
by this
with
too.
some of the things
And
we've
you
done
need to
so
remember
far.
that
That of the universe
the
will be
vacuum it
incredible.
looks expanded there
And
because
solar wind
there's
and
no longer
sun does
atmospheric pressure to keep the shape of that
like termination
flame.
system is
There's no more.
Stage 1 transonic.
and it sounds
Okay,
like stage
there's no
one is
more
launched.
pressure that they would.
So that science
How
is
do I
very
say
important to us
contain
here on Earth.
the
So
flame? So
looking
it's
forward
going to
to getting
expand
these deployed this evening.
outward, of course, for sure.
The landing burn
If you
coming
can
up
see.
here in a few seconds.
That's
The
why you
single
cannot see
engine
also
burn
the
and the last
bloom
burn that the
because
building
there's also not
needs
enough
to
oxygen in
land.
space.
Stage 1
Okay,
landing burn.
okay, and
There's that
also
call out.
landing burn has already started.
Landing burn has begun. Let's watch
Okay,
as Falcon
there
9
is the
touches
sound here.
down
Let's
on
hear.
landing zone 4E.
Okay, landing zone 40 says. Okay, looks like it is near to the launch site. Okay, let us see the near view.
Stage 1 landing light deploy.
Oh, boom, sonic boom time. Okay, looks like good. Okay, and the mission is already done.
Such an awesome
First stage
view of
booster
Falcon
looks like
9
it's already done
touching
its
down
job.
Landing confirmed.
on landing
Okay,
zone 4E,
landing has already confirmed. Yeah,
confirming
what a good
the
day
third
for
landing for this
for
booster.
the launches for
And
sure.
applause
And
here
ready
on
for the
the factory on the
Seco
floor.
one,
It's a fun
second
place to
engine,
see. You know, it would have been cool to see it
second
in
engine
Vandenberg,
cut
but this was
off
pretty
number
cool.
Yeah,
one.
I was going to say, I
Let's see.
love the launches, but you know what? I love the way
Okay,
SpaceX makes
Seco one
landing
chef
look
already
easy.
confirmed by now.
Yes, that's safe.
It's still
Okay.
one of my favorite parts, as many times
Yeah,
as we've
looks
seen
like
it.
we have already confirmed. There
Right
is
there on
a
your screen.
light blip
We lost the
of
signal
the.
for a second,
Okay,
but
and
basically we're keeping an
first
eye
out
on the
of
second
the
stage's
two
first burn. That's
second
continuing,
stage
and that burn's going
burn
to
has
last
already
until
done.
just after
So
T plus 8 minutes.
okay,
And then it will
so
shut down. There'll be a post phase, and then we will relight a second time.
yeah, and right now it's going to be ballistic course phase. How do I say ballistic course
All
phase right
right,
now?
so
Because
again, first
you need
burn
to
out of the
remember this,
way. We
okay?
will see a second burn later. That's going
We
to
need
happen
to
around T plus 39 minutes. We hope that you stay with us to see the deployment of both SPHEREx and Punch. But for now, we're going to send it back to Raquel and Farah because I know Farah is probably cheering right now.
Nominal
Yes,
orbit.
absolutely.
okay.
You are correct. Absolutely. If you're just joining us, I'm
Yeah,
Nancy
looking
Villanueva,
pretty happy.
joined by Farah Alabe, bringing you live launch coverage from
You're pretty
Vandenberg
looking
Space
happy
Force
right now.
Base along the central coast of
Yeah,
California.
pardon,
And
not
just over
not
9
really
minutes
my
ago at 8:10 p.m.
good
Pacific time,
health
we
condition, but
watched as a
okay.
SpaceX Falcon 9
It's
rocket
totally fine. I can
lifted off.
still swim
Farah,
at
I think
least
that is
around
the
this time.
happiest you've ever been. I've
And
known you for years.
right now the mission should have already been
in space, and of course we still have to get through separation. But oh my gosh, being in this building, everything was
almost
shaking. But
T
Mick will be
plus
jealous because really that
10
sonic
minutes.
boom as it was
It looks
landing,
pretty
it caught
good.
me by surprise. It was
Okay.
very loud.
Shook the entire building we
Yeah.
were in right
Uh,
now. How does it feel now to have
Okay,
off the ground?
so I
We still
think
have,
I
you know,
might be
30
able
minutes to
to
go before we
cover
separate. So
another
we
one.
still have to hold on for that. But it feels really great to have SPHEREx in space. We saw
Okay.
a peek at the photon shields when the fairing separated.
The
And I saw she was all in one
you did
piece. So
so we
good to
can
go.
talk slightly a
Fantastic.
little bit about this.
The rocket is flying
Okay.
two important
For
missions today.
this,
One is your SPHEREx, a space
for
telescope
the
that
next
will create the most
key
colorful
events
3D
also
map of the
around
cosmos
T
ever.
plus
And
39
Punch,
minutes.
4 small
The
satellites
stage
that will
2
study how the
first
sun's
restart will
outer
occur
atmosphere turns
around
into the
roughly
solar wind
40
that
seconds burn,
fills our
and then
solar
after
system.
that
So,
would be
a
followed
little pop quiz for
by
you, Farah.
stage
Do
2
you
engine
know what
cut
each
off
of those
the
missions
or
stand
cycle 2,
for?
and
Let's
after
start with
that
yours.
SPHEREx is
around
the
3 minutes after
spectrophotometer for the history of the universe.
the mission, it's
Epoch of
the launch vehicle
Reionization.
and the spacecraft
And
will
ISIS!
separate,
Oh my
which
gosh, I'm ISIS Explorer.
Got it.
which
Yes.
you need to know there.
Got it.
This is the SPHEREx,
And
and
now
for
how
the
about
punch,
It's
maybe
got the
it takes
polarimeter to unify
slightly
the
a little bit
corona
of
and
time,
the heliosphere. That
but
one
by
was
then I'm
Great.
almost
That
have
was
to
an
go
A plus
to
for you there.
my class,
Before
so
its
that's one
journey
thing for
into
sure.
space, SPHEREx
And then it
underwent
should says here
comprehensive
around
testing.
40 to
Farah was there
43
for the
minutes
whole
after
process
launch.
and will give us a
And
behind
there
the
should be
scenes look.
initial acquisition of signal from the spacecraft that will be
This is a
expected
clean
via
room
the
where
tall
SPHEREx is being
that
built and tested.
ground station
We
in
call
Antarctica. It
SPHEREx our
says here.
small but
There,
mighty
okay.
mission because it has
So
some
let's
really
go again.
ambitious science goals. The first is that we're trying to look back in time to
Yeah.
see what
So
happened
so
in the
this is
first second
this is
of
what
the Big
happened.
Bang. We also want
The
to
mission
understand
in the
how
nutshell here.
galaxies have evolved throughout history.
Yeah.
And
Correct.
finally,
Also.
we're looking for water and other basic ingredients for life in the places where stars and planets are forming.
BAE Systems partner with JPL.
So you can see this is it. This is how it looks like on the clean room before it launched today.
Spacecraft bus, which is
Okay.
everything below this metal ring you see around the
Yeah, that one
center
is
of
the
observatory.
spacecraft bus. It
In
says.
addition, BAE Systems built the telescope that's at the center of the SPHEREx observatory.
Yeah, you can see this is how it looks like when you actually separate all these three spheric
It has the
stuff there.
computer, the telecom
Okay.
system, the control
Computer, telecom,
system, the solar array on
SES.
the backside, and then the top part is the payload. The payload
Okay.
consists of the telescope itself. The
Yeah,
thing
that one is
takes the
payload,
images.
the telescope
telescope
there,
is at the heart of
and
how
there should be the
SPHEREx will
imager
observe
there.
the entire night sky.
I mean, this is
And then these
interesting.
cones are thermal shields that
Reminds
help
me
us
to
keep the
IXP
telescope
mission too.
cool.
The SPHEREx telescope and the detectors
Yeah, it
are
says
required
that
to be very
all
temperature
these
stable
three
during their
spheric
observations
be
in order to
used to
collect that science
protect,
data.
not only
And
to
they
protect
added this
the
very distinctive structure
payload
to a
itself, but
spacecraft
also to
that I
keep it
haven't
cool.
seen before in my
That's what it's actually used. And I
So
believe it should be
SpaceX
some
built in the
piping
clean
to
room, but we can't do all
pipe
of our
out
testing in there.
all
We
of
actually
that
have different
uh,
facilities
to
that help us mimic the
pipe
different
out all of
environments
that
that the spacecraft is
heat
going to see in
get
space.
out from the
The first
payload.
facility
So
that we
should be
get
good.
to when we come out of our clean room is
So
the
you can
thermal
see
vacuum
it's pretty
chamber.
interesting behind
Here
the
at
scenes.
BAE, it's called Titan. It's a special chamber where we
Yeah,
can lock
thermal
in the
vacuum
spacecraft,
chamber.
pull out
Usually
the
this is how
atmosphere,
they are
and
going
mimic
to
the
test it,
vacuum of
right?
space. It also can mimic the hot and the cold of space. So if you can imagine when SPHEREx is on orbit around Earth, it's going to see the sun, but also eclipses, so it gets really hot and really cold.
Yeah,
And we
so
can
that's
mimic
why
all of
you need
that
to get
in
it
that
there.
special chamber.
Otherwise, you
Down the
will
hall
have
over there,
that
beyond
kind
the
of
curtain,
weird
are
failure.
3 more facilities.
And
The
that's the last
first
thing
is
we
the
want
Fiesta area.
from this mission.
That's where we do our acoustics testing.
Okay, acoustic
It's a
testing
whole big
facility,
party for the
especially to
spacecraft.
test
We
out
surround the
what happens
spacecraft with these
when it got
giant
launched,
speaker
right?
stacks, and we
Especially we
blast
see
sound at
we
it.
just witnessed
Same
right
sound that
now
it's going
about
to see when it launches into space.
yeah, like this
Behind
launch
it is the
inside the
vibration
Falcon
pad.
9.
That's
So
a
that's why
special table
the
where we bend
the
down the
acoustic
spacecraft and
testing
shake it in all
facility
sorts of
also
different
important.
directions, mimicking
Yeah,
the
you
shaking
can
that
see
it's going
this
to
how
go through when it's launching on that rocket. And then there's the electromagnetic interference and compatibility test.
yeah,
It's
this
a
also
really
to
quiet
test out
room
the
that absorbs all the sound,
electromagnetic
and we put the
interference.
spacecraft in there and make
They
sure
want to
that
see
all of its
what happens
components, they
when
all emit radio
yeah
frequencies. We'll make sure that they
yeah
can
what
all
happens.
live in
Let's
the
say
same
if it's
environment and they don't
emit
interact with each other in a weird
radio,
way.
whatever so on,
There's
maybe
one last
even the
test that
sun.
happens here
So
in the
that's
clean
why
room,
they
and it's
have
called the
to test it.
separation shock test. What we do there
Okay.
is that we take the spacecraft and we mount it to the payload adapter ring. We then lift up the whole stack and mimic the separation that happens
Yeah,
between
so
the
this is
rocket
also how
and
it
the
happens
spacecraft.
to
When
be
that happens,
about
there's this
the
big
spacecraft
shock event, so
separation.
we want to make sure that the spacecraft survives that and also that all the pieces fit together.
Yeah, if I remember correctly, the way how they separate,
Years of
they
hard work
nowadays
really paid off tonight, and
they're
this
using
moment is so meaningful for the
pneumatic
SPHEREx team and the institution of JPL. This
PNEU
year began with
pneumatic
devastating wildfires across the
separation
Los Angeles area, including the Eaton fire that burned dangerously
separation
close to
stuff there.
JPL.
Yeah.
And Farah, hundreds of employees were impacted.
Yes, including members of our very own SPHEREx team. Some were forced to evacuate, and unfortunately, others lost their homes. And it all happened right as we were preparing to ship the SPHEREx Observatory from Boulder, Colorado to Vandenberg Space Force Base. Many of us were right in the middle of final shipment preparations when evacuation orders started rolling in. We even had to change our transport route to avoid fires, heavy smoke, and road closures, something none of us had ever expected to have to plan for.
Yeah, it's very unfortunate for them, especially the
resources and a
California fire.
helicopter landing area for
I mean, at
firefighters.
least, I mean,
Responders and our community
while
went above
while I
and
cannot
beyond,
compare our
helping those in
situation
need and
with
working
their situation,
tirelessly
it's
to protect
it's
JPL
very
and nearby
unfortunate.
homes.
I'm
And we'd
very
like
sorry
to
to
thank
hear
them for
that
their courage,
before that.
dedication, and support.
And also, maybe if you guys already hear some of the news here, basically in our in Sabah Sarawak, we do have a great flood that's actually happening mostly at the
and she joins us now.
not
Lori,
only
it is so
in the
great to have you
major
here.
city and also towns,
It's so
but also
exciting, and thank you for
even
that
the rural
wonderful
also
opening about
got
our first
impacted. So yeah,
responders and our whole brave
I
community. It's
absolutely
really special.
do feel that.
Lori,
No,
this launch is
very
a
very
true
sorry
bright spot for
for
JPL's family.
for
How are you feeling after
them,
watching that
of
launch?
yeah.
You know what? It's just
So-
it's such the culmination of the hard work
So
of
yeah,
so many people
hopefully
over
you guys don't
many,
get this
many
intent
years. And
wrongly,
even up towards
especially
the end, we have
since
had
this
quite a
is
launch
in
campaign here
internet
with
era,
lots of stops and
social media
starts. And when you're
era,
outside
so
and are able to see
I
that
don't know how
rocket
to
go up, and this one
give
it
better
flew
message
right
out of
through
here.
Orion's belt. Oh, gorgeous! It just
So-
makes it all worth it.
Yeah, you can feel the
Okay.
rumble here too.
So
Oh my gosh.
also,
And you know, SPHEREx is a great example of a smaller,
how do I
more
say?
focused mission with incredibly ambitious goals.
Let-
How do missions
let me
like
see
these fit into the
what's
bigger
next I can
picture of
cover
what
here
JPL does?
while
Well,
we're
at
still
JPL, we're
waiting,
really
right?
all about
Because
cutting-edge science, no
don't
matter what size the
have too much
spacecraft it
to
is,
say.
right? We want to
Yeah, I
do
wish
big
I
science
have
with big missions
people
like
to
Europa
talk
Clipper
about
and the
this
Perseverance rover.
right now, but
And
because we
SPHEREx is an
don't have
example of doing really
enough
big science
people,
in a
so
somewhat smaller mission.
I'm not
And
really
so it's
sure.
just great to see when there's the right kind of science question, we build
Maybe
the mission
maybe I can
to
cover
answer it.
slightly even
And SPHEREx
more.
is also a collaboration
Yeah, I
between
guess.
multiple partners. Can you explain to
Okay.
us how that led to the mission success and maybe how that might
Okay.
influence future collaborations?
Absolutely. I always say, you know,
Uh,
cosmic teamwork makes the dream work here, right? So collaboration is key
I
to
guess
everything we
I
do,
have.
whether it's with universities
Meanwhile,
across
we
the
are
country
waiting
and
here,
around the
right?
world, like
Why
what
don't
we've
we?
done on SPHEREx. We have international partner Korea involved in the SPHEREx mission, and
Why
of course
not?
our industry partner at BAE Systems
Why not we
and
have
the PI at
Why don't we
Caltech.
talk
So
bit
it
about
really is taking the best from lots of different
SpaceX, right?
organizations, and that's why our
The
motto
immense
is "Dare
time.
mighty things
I mean,
together,"
I try to
because
see
everything we
more
do
info
is about the team.
about the punch.
Well, thank you
Uh,
so much for joining
about the
us
punch,
today,
but
Lori. We
the
appreciate you
the
having
point
you
is that
here
there's
with us.
not many
You
I
know,
can
launch
talk
is really
about
just the
here.
beginning
So
for the
we're
SPHEREx
going to
team.
talk about SphereX.
Right now, Mission
Meanwhile,
Control
we're
is kicking
waiting.
into high gear at HJPL. For a sneak peek at what's happening behind
Okay.
the scenes, I caught
I
up with
will
project
try.
manager and flight director for SPHEREx.
Okay, I've
Can you
already
describe why
said
this space is so
here.
critical to the mission?
Well,
Okay,
this
so
room, the Earth orbiting Mission Operations
okay,
Center, will be the nerve center
so
for operating SPHEREx.
so
All of the
meanwhile
telemetry
of
that
waiting
comes from
here,
the space
let's
vehicle
talk a
will
little bit
arrive
about
here,
the
and all the
SphereX
commands that were
observatory,
sent to the
right?
space
This is
vehicle
how it
will
looks
originate
like,
here. On
and
launch day,
just
I'm up at
what
Vandenberg
it says
Space
here,
Force Base and part
it
of the
really protects
countdown
the
and
shield.
the launch management team.
People,
One of the key roles in this room
spheric
that we call
shield is
the
actually used
Mission
to
Operations Manager.
protect the hardware
That's
inside it
one of the
from
people
the
that I
light
will
and
pull
heat
during
from
the countdown.
the sun
Another
and
key
earth.
person
That's
is
here.
the
And
the deputy project manager. Since I will be at Vandenberg
okay,
when all the action
and
is going on
and
here, she will function as the project manager in this room. Another one of the key people.
and also it
is
says here
Arjun
that
Gorgian,
the cons, telescope, and
sitting at the
detectors
other end of
it
this room.
also sit on
Hey,
top
thank you
of
so much,
three
and
of
we'll actually go
structures
catch
called
up
the
with him and find out what he's
V-groove
doing.
radiator here. And
Varjan, tell
yeah,
us
just
the
like
role
what I
of the
said,
flight
there should be
director.
some
Well, the
piping
flight
there,
director puts
some
together
piping
a procedure
radiator
of
there,
all the critical events that
which
happen
consists of three critical
to make sure that the
mirrors
spacecraft is
that
healthy, that the instrument
that
is
is a
healthy,
resemble
as
like
well as all the people
upside
who
down
need to run the
umbrella
spacecraft are all ready to
and
go.
are
And
stacked
you know, this room
atop
really
one
kicks
another.
into high
And
gear
basically,
after launch.
Absolutely.
it's also
after
colored
that,
like this
when
to
we have all these people who are
redirect
ready,
all of that
they're waiting to
infrared
get the signal that
light,
the
so it bounces
spacecraft has turned on.
through the gap between the photon shields and also out of space, and also help the telescope to
like navigation to know
cooler.
where the spacecraft is, and then tell the ground
And
station where to look for the spacecraft to get all the important data.
yeah,
There's a
this
huge
is
number of people that have to
if you want to see
together
how
to make
the
things work.
SPHEREx
In this case, we
detectors
have
looks like.
the
It's like
systems which
this.
built the spacecraft and the telescope.
And this one is the
They're going to be
telescope.
here to
This one is
monitor all
the
that to make sure
detector.
it's healthy. We have people
It should
from
be able to
Caltech
imagine
who
the
built
sky
camera, which is
by
going to be
separating
giving us
all that
critical data. They're
colorful
going to be
infrared
here,
colors
as well as
here,
all the other
which
people
has
from
the
JPL
distinct
who are bringing this together to make sure that it all works
wavelengths,
together.
which
And finally,
you
can
know
you tell
it
us
would be
about a
translated
fun
into the
tradition we have
color
here
that
at JPL
us
involves
human
some
can
lucky
actually see.
peanuts?
Oh, absolutely.
All for
The
the
Lucky
study of
Peanuts
it,
have been
of
involved
course.
with JPL's exploration of space from the
And
very early
for the
days, and
mirror,
so we
it
always
says here it
think
has
of them as a valuable tradition to make things go well.
just the same like what it says here, effective diameter of around
Now, we also actually have some Lucky
7.9
Peanuts here
inches
with us,
or
and I
20
seem to our
centimeters.
snack on them all the way here.
Basically, the
Definitely,
view
we
of
need a
around
little bit more of
11.3
that
degree
good luck
by
for separation
3.5
punch.
Take us through
degree
separation,
field of view, and it says
now
here that
let's send it back to
each
Jesse
image
Anderson and
will
also
contain
a look
over
at
24
SpaceX's
million
history of
pixels.
supporting
I
the
mean,
next
nowadays
generation
there
of
is
space
way more than
exploration
24
with
pixels in
NASA.
whatsoever, but still useful for observatory, especially the astronomy. Okay, so
It's incredible having the opportunity to support NASA science missions to space, just like today's mission. In fact, last month was the 10th anniversary of the very first mission Falcon 9 and SpaceX launched for NASA, the Discover Space Weather mission, which launched in February of 2015, which you can see there on your screen.
yeah,
Since
that's how
first
it
taking
looks
flight
like.
in 2010, Falcon 9 and Falcon Heavy have completed more than 450 launches and more than 380 reflights. As the first orbital class rocket capable of reflight, Falcon 9 has helped drive down launch costs while increasing flight cadence, making space more accessible for all types of missions.
And for this,
Falcon
for
is helping NASA build our
the
future
telescope, and also
in space through
yeah, for this
programs like
telescope,
the
it will
Commercial
says
Lunar
here that
Payload Services
it's
Initiative and
split into
agreements like the
two
one
beams that
behind
are directed to
today's
sets of
mission,
detectors
the
and filters,
NASA
and
Launch
collectively
Services
called
2
the
contract.
focal
SpaceX is
plane
enabling
arrays.
access to
And it
space
says
at a
here
cost
it
and cadence that
features
no other
6
vehicle
detector
flight today can
arrays,
match,
each
unlocking
around
a wide
1.6
array of
inches
new
or
government,
41
commercial,
millimeters
and
square,
scientific opportunities in space.
and contains
Before Falcon 9, launching to space
4.2
was infrequent and
billion
cost much
pixels.
more than it does today.
So
Lowering the
adding up,
cost of
that's
access
how you get
to space
those
is
over
the
24
foundation for humanity's next
million
steps into
pixels.
the solar
That's one thing
system.
for sure.
More launches accelerate
And
development, enabling more small
on top
satellite
of
and
that,
private research
detectors, there's
customers to
going to be
launch their
color
work
filters
to
that
space, which in turn helps stimulate the wider space economy
SpaceX
here
to
on
conduct
Earth. And serving both cargo
spectroscopy, which will
and
split the
human
colors
spaceflight missions, Dragon has
into the
visited the International
rainbow-like
Space Station
color there. So
45 times.
into
In
its
addition to
component
NASA's crew
wavelengths
missions,
that will
Falcon 9 and
enable
Dragon are
the
advancing human
researcher,
spaceflight through private astronaut
especially
missions as
the
well,
astronomer,
including
and
the
maybe
Axiom missions
some
Inspiration
overlap
4,
with the
Polaris Dawn, and our upcoming From
how do I
2
say,
mission.
maybe with
And missions like SpaceX's Transporter and Bandwagon
Hel
rideshare programs help make access to space
Study
even more
what's on,
affordable
also
by sharing the cost of a single launch across multiple customers.
also can
All
be
of this to
useful.
say, reusability is the key innovation that's
Okay,
making space more accessible. Now we are
and it says here
just 23
from
minutes
interesting
into
thing
today's
that I can
mission,
say,
and
that I can
in
see that each
a
filter
few minutes, in
has
about
70 color
15
bands,
minutes or so,
which
we will be
distinct regions that
reigniting that
looks
second
like
stage
described it says here,
to continue
and
the journey
it will
with
be very
SPHEREx and
the
Punch.
wavelengths it
We'll send
says
it
here
back to Raquel.
very continuously over the filter of the
Thank you,
gradient,
Jesse.
similar
Punch,
to the
along with students
to a
from the
gradual
University of Colorado
transition
Boulder,
between the
are
colors
bringing
of
ancient
a
solar
rainbow. So you
observations
guys
to
already
life.
know about it.
Their project, Solar Stones, transforms historic petroglyphs into
So this is
art.
how it looks like.
Let's take a look at how it's connecting the past
It
to
will
modern science.
split the color all together here. You can see.
Sitting next to me here are what we call our solar stones, and although we did not
and also the way how they will move the telescope,
tablets, we replicated
the mirrors and the detectors, how they will it will move the entire whole spacecraft together. But instead of using the thrusters or chemical propellants, because it's going to waste a lot of resources, right? Fuel is pretty precious. It relies on the system of gyroscopes, traction wheels, and also magnetic torque rods. I guess if you ever play
look at this, it has
global space
all the
program,
telltale
or maybe
signs of eclipse.
even
It has
Juno,
an
New
occultation in the
Origins,
center,
New Horizons, whatever.
blotting out the sun, this
You know
very
what
circular shape.
they're talking
It
about, right?
has the
Those
solar
instrumentation.
corona
I've already
out
explained
and
it
along the
once.
sides,
It's
and up
interesting.
here on the top is what is believed to be a reflection of Venus.
While these tablets would be really good for any learner, we collaborated
yeah.
with the
So
College
this
of
one
the
is the
Blind so that we could make these tablets accessible to low vision learners.
Space is typically a very visual field.
Yeah, I guess
You
this
look
is
up at the stars, you have pictures
this is
of
about the
space,
community
but
outreach
if you
here.
can't
So I
see that,
define
then you're
you
pretty
guys
much
also
completely
can see that.
blocked out from being
And
able
I'm
to
going to
study
talk a
this
little bit about the SPHEREx telescope
understand
and the
this
detectors.
part of history. And so
It
this way
it
we
need,
have
need to be kept
exhibit
around
that
minus
people
350
can
degrees
learn from
Fahrenheit
if
or
they're
around
sighted
minus
or not sighted.
210 degrees Celsius. So around
It took a lot of time
how do I say
to
this is
figure out
around
how much detail we needed, how deep
how
the
do I
object
say
needed to be,
around
what textures we
around the
needed to
temperature
use.
of
A lot of
liquid
these things that we
hydrogen
didn't
or
expect,
liquid
we gained
helium,
context through lots of user
nitrogen,
testing. So I
no,
think this
liquid
project is
helium
really
or
valuable because
liquid
it
hydrogen.
allows people to interact
Pretty
with
cold.
space in a completely different
And
way.
it says there, otherwise, if it
Every
not
person
cold,
has something they can contribute
became
to the
cold
study of
around
space.
the
And so
temperature,
our
it would
hope
generate
is that
an
not only
infrared
can the
glow
blind
that
and low vision
might
community be
overwhelm the
included
faint
in
light
this
from
part of
the
history,
cosmos,
but that sighted learners
from the
can
cosmic
potentially
process.
learn things easier
It
with a
says here, for
tactile
comparison,
experience.
like the temperatures in Antarctica, it would dip
Well,
as
those
low as
solar
minus
stones are so cool, and with us
20
now is Punch
Fahrenheit
principal
or
investigator
minus
Craig DeForest.
85
So
Celsius.
glad you could join us,
And
Craig.
Thank you for having me.
what the
I
parts
see
of
you brought
the
some examples
surface
with
of
you
the moon
today.
I
usually
do
end up
indeed.
night
So Punch is studying
at peak
the
will
sun,
reach around minus
astrophysics at
280
home, right around
Fahrenheit
us.
or
And in that, we're
minus
carrying on a tradition that goes all the way back to the
173
ancients. So this is a
degrees
3D
Celsius,
printed representation
which should be
of,
around
what may be
around the
oldest
temperature of
representation
liquid
the solar
nitrogen
corona,
and
in a durable medium.
if I
This
remember
was
correctly.
recorded life-size.
And yeah, the design is
about 1,000 years ago
entirely
shipped
passive,
this into the
and
rock right
fortunately
near what is now
no
the visitor
electricity
center,
or
Chaco
coolant
Canyon.
required
This
during
is
normal
consistent
operations.
with, and
Maybe
we
just
believe
some
it to
slide of
be, a
calibration, but
representation of
it's
a
fine,
solar
you know.
eclipse of 1097, which occurred over Chaco Canyon.
And it says here that
Actually
before it
witnessed
even can begin
and
operation,
observed
usually
corona
a
around
set
us. So
of
that ties
electric
us
decontamination
from the ancients to the modern
decontamination
esoterica of
heaters
space
will be used for a few days
Why was it important
because
for
they want
Chaco
to
Canyon to be
reduce the
the
risk of
location
ice
for the
forming
Punch
on
mission
critical
solar stones?
components
So we
during the
organized
initial
our outreach
instrument
program
cooldown. So
around
it will
ancient modern satellites.
initially be used for a
Chaco
few
was a
days
large
so
center
that
of
they can
culture
continue
about
off
1,000
once
years
they
ago.
feel it's safe.
The folks
That's
who
one
lived
thing
here
for
at
sure.
that time had a long history of science, the technology
Yeah.
that they had in hand.
And right now, the
and of
cooling
observing the sun
structures, you
around
need to
them
know,
predict
the
their
photon
environment
shields
in the
itself,
future in much
each
the same way
around,
that we do
each about
today. Though of
0.75
course, they were looking for
inches
things
thick,
like agricultural
thick or
planting
around
times and
19,
things like that.
19 millimeters
But
thick.
that
Should be
thread of
around
human
1.9
curiosity looking at the
centimeters
environment around
of
us
thick. It
extends all
will
the way
surround
to
the
what we do at
telescope.
NASA
It
today.
says here, block
Speaking
light
of
from
what we
the
do at
sun
NASA
and earth
today,
from
so
UV
Punch has a
or even
coronagraph that
warming.
sort of mimics a solar eclipse, right?
And
that
it
allows us
says
to
here
study
that the
corona. Can
cone,
you explain how that works?
Certainly.
yeah,
So normally
the
we can't
cone
see the sun's
actually
corona
features
or the much
two
fainter solar wind that
aluminum
Punch will emit.
sheets. They are
And the reason for that is the sky is very
separated by
bright. The sun is very bright
aluminum
in the
shaped
sky,
like
the
a
sky is very bright.
honeycomb.
We
And it
normally
says here
can't see
that
the
the
corona
reflective
unless the
aluminum
moon blocks
will be
the
able
sun
to
out. Standing in the shadow of the moon, we can see
will be able to
around
bounce the light and also
planetoid
heat
to see
out
the solar
into
corona
space. And the
extending out into
exterior
space.
of the
That doesn't
outer cone,
stop. That
it says here,
extends
painted
all the way
white
out
to
and
reflect
washes over the earth. So
sunlight
Punch
and radiant
is in space.
heat.
We
I
can,
mean,
instead of the moon,
this is a basic
apply a very carefully
science that
crafted piece of
everyone
metal
else ever
to
done
cast a
before.
shadow
Even
on our
even
camera
if you
and
even
allow us to see the corona
try
24/7
if you
around the
even
clock.
try, how do I say it?
You know, we really appreciate your expertise.
Even
We
if
have
you
some
try
Punch
to go up
questions
there,
coming in for viewers.
look
Do you mind if we answer
at
a
the
few right
building.
now?
Let's do it.
If you notice why
Let's
they
see what we have here. We have Rosanella Costa on YouTube wants to know
why do they
satellite
actually
improve our ability to predict phenomena such
why
as
do
solar
they
storms and their
paint
impact
building
on
white? Because of
Earth?
that, they want to
So,
reflect the sunlight and
Punch
also
will
radiation.
allow us
That's one
to
thing for sure.
forecast space weather much better than we can now. Right now,
Okay.
We look at the space near the sun, the corona, and observe storms forming and leaving the sun. They streak out across the solar system at 1 million miles an hour or more. And then we extrapolate all the way across the void to our planet.
It says here,
we don't have a way of measuring them in transit.
the most important point is that because they pointed away from the sun is more challenging. SPHEREx, what it will try to do is it will orbit from north to south, from over Earth's poles along the terminator line, which will separate day and night on a celestial object. Says here. And from that orientation, the opening at the top of the photon shields will continuously point at least 1 degrees away from the sun, as you can see how it looks like. And it says here, inside the protective shields, the telescope is slightly tipped toward the sun, so that the full sky can be observed. So that's how it's that's how the observation is being done using that technique, right?
That meant there was an enormous
and it says here that the flying at the terminator line also means that SPHEREx will be exposed to similar amount of light and darkness during each orbit, which will keep the spacecraft's temperature, it says here, more stable than if its orbit passes through varying light levels. So that's why they want to fly on the terminator line. That's one thing for sure. Okay, looks like we are almost at the event. Pretty good.
Welcome back to SpaceX in Hawthorne, California.
Oh, and also the communication and data you hear previously about how they do things about it, about the payload, the spacecraft bus itself. There is computers, there's even ACS altitude control system, and also the communication and the data. Also, it says here it will try to communicate with Earth via 5 microwave antennas, which 3 of it will be S-band and also 2 will be carbon. The 2 S-band antennas will be located on either end of the solar panel and will be used to send telemetry, which will indicate the status of the health and also the status of the spacecraft. While the higher gain S-band antenna, which sits on the bottom of the spacecraft bus, will be useful to receive not only commands but also to receive images and pictures gathered from the telescope itself. Okay, especially for this science data. And while it has the higher data rate than the S-band antennas, however, they are actually the cone shape for the carbon, while the S-band actually omnidirectional. So basically, they are using S-band because it scatters to everywhere else in the direction, which means that if they want to capture the signal, let's say especially on the horizon, even on the horizon, if they are able to capture it, it's still better than nothing. So that's why they are using S-band antennas for in this case. So they are able to communicate with the ground for even longer periods of time here. And it says here because SPHEREx has a 98-minute polar orbit at Earth's day-night line.
Thank you so much.
It will mostly frequently fly over areas close to the poles. And basically, take advantage, it will communicate via ground stations in Troll, Pika, Troll, I know, funny name, Fairbanks, Alaska, Punta Arenas, Chile, and also Svalbard, Norway. Which, if I remember, Svalbard is actually island located slightly. Okay.
These concentric cones help SPHEREx
which is basically an island of Norway, if I remember. And also the Svalbard, also the place.
SPHEREx has 3 cones.
And also Svalbard also is the place where we can also see there is also sounding rocket launchers too. But soon enough, I heard that Svalbard will also be used for the orbital satellite launch, orbital launch site also. So we're going to see it that soon. If I remember correctly, Svalbard is also one of the places where all trucks also kind of try their rocket there too, but unfortunately never completed, and hence it's just nothing more than just basically a glorified sun rocket at that point. Yeah, so let's say if authority didn't cancel any of their plan, maybe we'll see it's going to launch on this Svalbard, and Svalbard would already long become the orbital launch site.
Cooling them to minus
but yeah,
350 degrees
history, man.
Fahrenheit. That is cold.
Yeah, that's how it looks like.
Help us study everything from what
And
happened
also,
a few seconds after the
it says
Big
that
Bang,
the ground stations also are part of NASA's Near Space Network in comparison to Deep Space Network. This one, Near Space Network, would basically communicate anything around the Earth orbit.
You can just keep calling it SPHEREx.
Which is managed and operated by NASA's Goddard Space Flight Center in Greenbelt, Maryland. And it says here that during each ground station pass, the S-band can transmit data for about 10 minutes.
That's not a mistake.
10 minutes, and the carbon can transmit for about 3 minutes. So you can see why.
Sure, let's wrap this up.
So you can see why. The S-band, it can transmit data about 10 minutes in comparison with the carbon 3 minutes, which shows what's around almost 3.5 times lesser time
Absolutely. And
they
actually,
can
SPHEREx instrument scientist
use
Bill
to
Horn got joined
transmit
us
all
to
that
talk about
science
that
data.
cooling
That's why
process.
they
Being
need
here,
all of
Phil.
that groundbreaking station all over, of course.
Totally passive,
and also it says here that
we have no refrigerators, we have no
per day,
like
an average of 5 pulses do occur around that time after the launches, especially. So this is how it looks like the near space antennas at the Alaska satellite facility in Fairbanks. You can see here.
And then inside
Looks
there, you
good
can
there.
see that we've got a model of a
Okay,
telescope.
and it says here that observatory will
back
take
in
around
Pasadena, we took
600
this thing
science
to do a little
exposures per
demonstration to
day.
show you how
And
that
because
would
there is 6-1,
put
of course,
it
you
up on the
just
roof of the
maths,
Green
you know,
building for
6 by
astrophysics, which is actually the building
600.
that we assembled
How
the
much
SPHEREx
does it total?
instrument in. And we put it up there with a great view of the night
3,600
sky.
individual.
So there's thermal engineer
That's
Brad
one thing
Moore
for
and I
sure.
getting everything set up.
And
the point
it
is that
says that
using that
the
night
onboard
sky, even here on
software
Earth,
will
we can
take
cool it
a
down.
series of
So here in this
steps to
time lapse,
reduce
as we left it
the
out
amount
there
of
overnight,
data
you can see why this is harder
that needs to be sent down to Earth by a
Those clouds up
factor
there, the
of
atmosphere
about
is actually pretty dark in the infrared.
175.
Not to mention that
Wow.
air
The compression technique. And also it says here that this includes a compression algorithm. We don't know what compression algorithm they are using here. I don't know. I don't have idea.
What's happening with the heat
But
glowing off of the telescope
but
inside. So you
how do I
can
say,
see
maybe
here, as we look
maybe
at the
for my
infrared,
educator
there's a lot of
cases,
light
maybe
that that
they are
telescope
using
keeps
this
warm. And as the
raw
time lapse goes on, you see that light coming
compression
down,
technique,
that
or maybe
glow
even
that's coming off the infrared
the
as
newer
it dumps
one,
out
the
of deep space.
lossless
You look to the outside of this, there's a glow around the
AVIF
photon shields, and that's
derived from the
Earth coming
AV1
up.
video encoder
And so inside, it looks
algorithm.
dark
I
because
I
it's
guess
reflecting
this is how they are going to use for the compression. And also the algorithm that estimates the flux in each pixel, and it will try to reduce it to a single value of instead of roughly 70 values per pixel that are initially produced by the detector. So you know why.
Brad and I coming in, you can see the glow from our hot coffee. This is an infrared video, so you see all the light that's actually glowing off
looks
of
like
us
my-
at room temperature. Here we are looking in
I
there to see what we
have
found,
to
and
go.
that's what it looks like.
But
That
we'll
radiator
try
is
to
nice
stream
and
this as
frosty.
much
You
as
see when I
possible,
swipe
right?
my
So
finger across it, there's all
okay.
that dew on there, and that's because
the
we
set
cool
the
down
go
using
operation
passive
systems here. We can see the satellite
below the
operations.
dew
It will be
point, and we
operated from the
condensed water and
Earth
made a little
orbiting.
frost on the outside,
This is how it looks like. Pretty cool, right? Maybe you might be asking why all of that perch? Okay, why of that propellant perch? Because you need to remember that without that perch, not only the tank will basically become overpressure and possibly cause the tank explosion there, but you need to remember that without this propellant too, imagine if you try to light the engines, especially the vacuum. There's not even enough amount of fuel needed to still keep it pressurized, so it will be able to move, right? So that's why they are doing this. They want to keep the fuel and the propellant lines all moving forward, and also to prevent how do I say? And also to prevent the overpressure of the tank. So
Well, Phil, thank you
let's
so
see.
much for joining us. Now, let's head back to the
Okay,
team in
around
California for
the-
a status update.
yeah, should be ignition of the second
All right, we're
stage
now 39
engine,
minutes into the mission.
around
Coming up is
40
what's called
seconds.
SES-2, and that's when
Okay,
SpaceX will
SES2.
reignite its second
Let's go.
stage engine, which you see right on your screen there.
Okay, it should be ignition right now. Okay, should be.
We are expecting that
Oh, here we go.
SES-2,
Here we go.
this is the
Okay,
second
ignition.
burn for this mission to ignite.
This is
There it
second
right
engine
on
start
time.
up
You
number
can
2.
see that there on your screen. Now this is about a 50-second burn for this burn. And this extra burn, this is a single Merlin vacuum engine, has about 220,500 pounds of thrust. And burning just for about 50 seconds doesn't seem like much, but it's just enough to take the second stage with the payloads attached to its
And also because they need some precision to also go to the orbit. Without this maneuver, you cannot even achieve SSO insertion or sun-synchronous orbit or Helio-synchronous orbit insertion. So now we have also sequence number 2, second engine cut off number 2. And of course, I'm pretty sure there's also going to be SES-3, mostly to deorbit the satellite. No, mostly to deorbit the upper stage, my pardon. And also after that, it's also going to be a preservation where they are going to dump all of their fuel and whatnot. And you can see, it looks pretty beautiful on the Earth. And there should be the separation of the SPHEREx first, and then after that, we are going to see punch satellite separation too. So we'll see.
This timing helps prevent the exposure to excessive solar radiation, keeps our thermal
Oh
conditions
no.
that we just described within our limits.
Is there even any enough time there for me to cover punch?
Confirmation of second engine cutoff, as well as good orbital insertion, as Mick called.
Okay,
On its way up to
let me
that
go
sun-synchronous
back to
orbit.
that.
Out there.
Okay,
And we are coming up.
because I'm just calibrating.
In a few minutes, we will have, in about 30 seconds, we will have payload deploy of SPHEREx. We've got some great live views there
so
on
looks
your
like
screen.
if
Earth looks amazing there.
if I'm
really
right
great
there,
view.
the first 2 out of 4 punch satellite would be deployed first, and then another 2 no longer after that will also separate.
SPHEREx was designed
So it should
to
be
operate for at least 2
SPHEREx separation
years, but
here.
the team says if all goes well, it could operate much longer.
It should be separation anytime soon. 42 minutes should be. Here we go.
Expecting deployment here in just a few
Okay, deployment of the SPHEREx confirmation. Visual confirmation here. Okay, looking pretty beautiful. Yeah, it is nice.
There on your screen, SPHEREx is drifting away from Falcon.
Nice, and there should be initial acquisition of the signal,
It's
right?
everything in me not to talk over you.
Yeah.
So exciting.
Are you kidding? Farah is at the hostess right
Ooh,
now, jumping up
it's
and
pretty
down.
interesting, right?
Yeah, again, great live views. It's always nice to see, and again, this is a great opportunity for the spacecraft team to see it happen in real time. So
Yeah,
now
looks
the
like it.
spacecraft has a 3-minute pass over a ground station in Antarctica. You might have heard it mentioned a couple of times in the broadcast. Troll is what
So
that ground
I
station
need to
is called.
prepare.
And the team hopes
I
to
think about the
confirm an
ground
initial
station, what's
signal
on.
with the spacecraft.
That's no longer
Yeah,
too
the initial
important right
signal
now.
will primarily be
But for
gathering
one
engineering
thing's
data
for sure.
health and status at
Sorry,
this time.
if you cannot see.
And once they
Okay.
confirm that,
For one thing's for sure, the science data processing, it will be processed at the Caltech's IPEC that will perform scientific data processing and also analysis. And also will be released to the science user community and archive. And to the science community, and also archiving will be carried out to the NASA/IPEC infrared science archive IRSA. And for the satellite operations, it will be operated from the Earth orbiting mission operations center at NASA's Jet Propulsion Laboratory, JPL in Southern California, and the spacecraft support will be provided by BAE Systems in Boulder, Colorado, and also the payload support will be provided by Caltech, and the survey planning support will be provided by Arizona State University in Tempe. I don't know, Tempe. I'm going to call it Tempe, whatever. Just similar to how I like to pronounce the food Tempe, right?
Jamie Bach, and he's the principal investigator for SPHEREx.
So
I don't know about you guys, but I'm going to be looking at him for a reaction.
I don't know. I'm going to be looking at that whole room. I think they're going to be just as excited
yeah,
as
He
I
everybody.
think
waved. I
maybe
think
that's
he
all,
heard us.
guys.
You're watching.
Thank you so
him, he's
much
watching us.
for watching,
We're
and
waiting
I'm
for
going to
that
end the
JOS
stream
for that
as
engineering
soon as
checkout, and
Punch
that team in the
finally
director center there
deploy
at
here,
836
because
for Vandenberg
or
Space
maybe
Force
even
Base,
before
I know is
deployment of the
excited
Punch.
to see this
Who
deployment
knows?
also.
Let's see which one will
He's
happen first.
in that first row. He's joined by some more spacecraft team members, as well as from some leadership at
Yeah.
JPL. So really glad to just see the whole team there,
Oh.
waiting for again this important milestone. Again, we have this 5-minute or this 3-minute pass with this ground station. So anywhere in this time, if we're able to get a high,
I think
hello, quick
I might
acquisition of
open
signal,
up the music
that would be a
because
great
there's
sign
nothing
for the
too much
team.
right
And
now.
then those subsequent passes over different
Oh
ground
yeah.
stations.
No, it's less
Again,
important.
Norway as well as Antarctica, or no, Alaska, Fairbanks, Alaska. Will give them an opportunity to get even more information and more data from the spacecraft.
Beautiful views from second stage there.
Yeah, you can see.
Performed very well tonight. Still
It looks pretty
continuing this
beautiful,
mission,
right?
with that second
Nice.
burn. We still have Punch on board, and things looking great there as second stage continues to coast.
Yeah, Mick, some of my favorite things about launch is really the views from space that you don't get to see from down here, but we get to see it from the
Yeah,
spacecraft
so
out
if you see
in space during these missions. And
if you
these
see
were some
my
incredible views
avatar
tonight.
like that right now, because
Yeah, it really puts into perspective. You know, what we're doing here,
Because
we
I'm
are sending
basically so sorry.
spacecraft that do incredible science out into an orbit around the Earth, and all the data that's collected.
issues,
You
yeah.
know, this is science that
going-
touches all different kinds of disciplines. Specifically for SPHEREx, right? It's
good.
again just being able to see and map our
I just put
universe
it,
in a way that we've never done it before. It's going to
put it
really
closer
answer
to
some
my
of astrophysics' biggest questions, and then
to
for
my color
Punch,
color t-shirt.
studying our sun and
I would like
understanding
you guys to
how
hear
it can
this.
affect us
Okay.
in terms of space weather, you know, comms going down, telecommunications, satellites, things like that, all affected by space weather. So Punch is really going to help us
Okay, so
understand
that's
how to
what it
better
looks like.
predict when space weather might affect us.
Ooh. Oh.
And it looked like we did lose acquisition of signal from the second stage, but the mission isn't over yet. Falcon 9 second stage is still carrying NASA's Punch mission, 4
Yeah,
satellites
of
that will
course.
study our sun's corona.
If I remember,
Those will start
originally
deploying
Punch
around 52
should have
minutes
already
after launch,
should launch
so
together with
be sure to stick
SpaceX's,
around for that just a few minutes from now.
spacecraft. But what happens is that there is a little bit changes occurring, so that's why they have to launch it with SPHEREx instead of SpaceX. But
So, of
I
course,
think
we
it's
would
still
have liked
better
to
than
hear it from it right now, but this
So
it's a
that's
very
one
short
thing.
pass, as you heard, and so the SPHEREx is continuing to orbit around the Earth. It's getting
want to-
itself into the right
Oh.
configuration. It's going to go over another ground station called Svalbard up in Norway in about 40 minutes, so we'll hopefully hear from it then. And so we'll be anxiously waiting to hear from her and
Okay.
to tell us that she's doing well in space.
Well, thank you so much for that update, Farah. And joining us now is project scientist Olivia Doré.
Yeah.
Olivia,
I'm in a company
thank you
with
so much for joining
the
us.
music also not bad, right?
So Olivier, tell us,
So-
SPHEREx is taking a
So that's
3D
it.
map of the universe, right?
Almost
How
12,
and why is it
12
doing that?
p.m. right now.
Yeah, that's a very good question. Thanks, Farah. And this question is really at the core of SPHEREx mission goals and also its design. So let me start with the why. And to explain you the why, I will use this crystal ball here. And don't worry, I'll use a crystal ball to explain the past and not to predict the future. So, but if you look closely at this crystal ball here, what you see inside, you see all kind of small filamentary structures, elongated structures
Yeah, so that's
that
how it looks
connect
like.
and intersect. Some kind of three-dimensional spider web. So
Mm.
this turned out to be a really good visualization or representation of how galaxies are
Yeah,
distributed
so
throughout the universe.
basically the representation of
And
the
in fact,
galaxy.
we call that the cosmic
One
web.
thing's for sure.
So what SPHEREx wants to do is make a three-dimensional
Oh.
map of the cosmic web
Okay,
over the
pretty
whole
good.
sky. And the
Thank you
reason we
for
want to do that
anyone
is simply
that's
the
watching
fact that
here.
by making this
I'm
map of the
really
cosmic web over the
appreciate
whole
it.
sky, we can get very
So
unique
let's go.
insight about the very first moment of the universe, when the universe was only a fraction of a second old. So that's really what we want to do. And so to get to the first part of your question, the how, so that we will do that by really mapping the whole sky
in 102 colors. And so why do we want to use colors? It's very simple. So if you look at the sky, you take a picture, you will
I think we are not
exactly
very
where
too
stars
long
and
here.
galaxies are. But if you
I'll
want to
try
know
to
how
cover as
far
soon
they are
as
from you,
possible
if you
here.
really want to measure the third dimension, you need to use a color information. By using colors, you can really tell how far a galaxy is from.
Yeah.
You can really tell the distance between you and a galaxy, and so you can construct. If you
Yeah,
map
correct.
all sky with this 102
That's
colors,
it,
you can
correct.
really construct all
Okay, so that's how it looks like there.
map of the cosmic sky. That's
Punch
really what we want to do.
spacecraft there.
And how does SPHEREx use color when mapping?
Right. So.
My watch.
Right. So yeah.
Let's use my
We
watch.
will use, to make this map, we will use what we would like to use, rainbow colored glasses. And so you can think, when you use rainbow glasses, what's very interesting about it is that the color you see slightly is different depending on exactly where you look at. And so you could say that
for sure.
we use some kind of astronomical grade rainbow glasses that we put in front of our detectors. And so it means that each part of our detectors will see slightly different colors. And so by planning a very
I think this one I can try.
Exposures.
Yeah, thank you so much for everyone posting and even favorite my post.
What we will do is that
I can lock out right now, so just lock out here. And how about here? Notification.
Great. Thank you so much for your insight,
Okay,
Olivier.
thank you very much.
So we are actually now heading back
I'll just sign out.
to Hawthorne, California for an update.
Okay. Done. And we are ready for the deployment of the Punch spacecraft, so we'll see here. After the deployment, I will end this stream as soon as possible. Yeah.
NASA's SPHEREx and Punch missions from Vandenberg Space Force Base. About 9 minutes ago, we watched SPHEREx separate from the Falcon 9's second stage, and the SPHEREx team then confirmed, and we did not confirm acquisition of signal just yet.
Okay.
We will confirm that at the next opportunity.
Yeah. But as long as it's still healthy, I guess
they're going to deploy
it's fine.
in two batches, right? So the first two are going to deploy around T plus 52 minutes and 16 seconds. So that's about 45 seconds from now. And then the other at T plus 53:07.
Yeah, pretty good. So I can say we are pretty close right now. I still should have time to test the bus. So yeah, just the bus, because that's how we students have to handle. We need to go to class. Otherwise, you have to pay all of that extra charges for just to go in e-hail, right? So let's go. Should be separation anytime from now. Let's go.
One set and deploy a second set a few seconds later. That will help.
Should be separation and deploy of the first two set of the Punch. Okay, there's already separation. Okay, already 2 out of 4. You have already confirmed deployed and ready. Another 2 out of 4, which will be total 4 of 4 deployed. So let's see. I will end this stream as soon as possible. So let's go.
I'll tell you, seeing that was just as incredible as seeing SPHEREx separate those two satellites.
Let's go.
Separating, and then the next two coming up, getting that constellation out there so Punch can do their science. That's very important, and I know the Punch team is looking forward to that.
Yeah, let's go.
Yeah, and we are deploying these in a bit of a different orientation.
Here, already
from
does the
SPHEREx.
music.
We did see SPHEREx drift away.
Okay, ready?
Very slowly from the second stage.
Yeah, separation, and finally, all 4 out of 4 Punch satellites already finally separated. So that's beautiful, amazing there. So, so that's it. I'm not going to comment any further right now. Just need to chase that bus right now. So, so thank you everybody for watching. Okay, so see you guys next time on the next stream. If I remember, it should be Crew 10, SpaceX Crew 10 main mission to the ISS. So that's all, guys. Thank you for watching. Need to head for the class, and goodbye. Take care. Bye bye. 3, to